This is section 1.3, graphs of functions. We start off with the vertical line test. So we've already talked about this a little bit. It's to tell if something is a function on a graph. So a set of points in a coordinate plane create a function if and only if no vertical line intersects the graph at more than one point. So if we draw a vertical line through our function, we should only intersect at one point. Here you can clearly see 1, 2 points. So this would not be a function. Here, we draw a vertical line. You can see it only intersects at one point. So yes, this is a function. Here, draw a vertical line. You can even draw a couple just to, get your point across. And you can see that 1, 1, 1, yes, this is a function. So when you draw a single vertical line, these ones are a little bit slanted, but they should be perfectly vertical. It only crosses in one spot. And then here, you can see once again, it crosses in two. So nope, it is not a function. So we have increasing and decreasing parts of our functions. So an increasing part of a function is when it's increasing on an interval. If as the x gets bigger, the y also gets bigger. So as we're moving to the right, our function is going up. So this is the example of an increasing part of our function. As we move to the right, our function goes up. For decreasing, a function is decreasing on an interval if as the x gets bigger, the y values get smaller. So as x goes to the right, we're going down. So when we go to the right, we're going down. So anytime you think of x values getting bigger, we're going to the right. And then a function is constant on an interval if as the x gets bigger, the y stays the same. So here, as we move to the right, our y is staying consistent at 1. That is a constant part of our function. So once again, as x gets bigger, you can think of that as we are moving to the right. And so as we're moving to the right, y either stays the same, it gets smaller, or we go down, or it gets bigger and we're going up. So up, down, and the same. So when we want to write the intervals for which a function is increasing and decreasing, it's kind of like when we do domain, we want to write, we're going to set it up just like this, like an interval. So this is saying x is in the middle, and I use these less than symbols to say that it's less than our biggest number and it's greater than our smallest number. So our smallest number always goes on the left, our smallest x, and our biggest number always goes on the right. So whenever we do this, we always look from left to right because that's as x is getting bigger. We're going to start with our leftmost point, which is -5. So once again, always looking on the x. So -5. And we see as it goes up to -2, as we get bigger in the x, our y is getting bigger. We're going up. So this is an increasing. I'm going to put an I for increasing. This is an increasing interval. And we don't put equal to here for intervals because technically these endpoints, which we're going to end up calling relative minimums and maximums, they are not included in this increasing part of the interval. They're kind of like our the points where we change from increasing to decreasing or increasing to constant. So we don't include those. So we can just use the less than rather than less than and equal to. So we go -5 to -2 is increasing. And now you see that the graph changes here. So from -2 to 2 on the x, now we're going down, we're decreasing. So our next interval will look like this. And we can write a D for decreasing. So now starting at 2 going to 4, we are staying the same. It's a horizontal line. So we call that constant. And then our last interval, 4 to 5, we're going back up again, so we're increasing. So 4 to 5, we are increasing again. So that's how you would write out the different intervals. We can do the same thing for this example here. The difference is the ends of our function here had points, Now, when you have an arrow is when you need to use the infinity symbol. So we always start on the left, go left to right. Since there's an arrow on the left, that means we're going to negative infinity. And so here we go down about to -1. So we like to think of this kind of like the bottom of a valley here when it starts to go back up again. So we're going down, and around -1 we change to go up. So that's where we're gonna have our highest point, and from negative infinity to -1 we are decreasing. So if you notice, when you do these intervals, -2, -2, and then over here we have 2, and then we start with 2 here. So you should always start your next interval with whatever you ended with over here. So we ended with -1, so now we're going to start with -1, and let's look on our graph. So -1, it looks like to about 1, we go back to increasing. It's where our function is going up as we move from left to right. And then 1 to, since we have an arrow, we're going to write positive infinity, is decreasing again. So it's a little bit trickier when you don't have these hard edges here. It's more of a curve, but it's really just like the top of the hill is where you want to switch, and the bottom of the valley, how I like to think of it. And if you have the arrows, make sure you're using negative infinity and positive infinity as your starting and ending points of your interval. So once again, here we have an arrow. So we're going to start on the left with a negative infinity. And it looks like we're going down to 1. And since we're moving down, going left to right, it's decreasing. Keep in mind, we're only using x values. We're not going to use any y values when we talk about these intervals. So I ended with 1 here, so I'm going to start with 1. And now from 1, looks like up to 3, we're going up, so increasing. And then from 3 to 4, we're going down again. So that's a decreasing interval. And then from 4 up to infinity, we are increasing. So I like to think about it, our x values are going left to right, what's happening left to right, and then decreasing, increasing, and constant is what's happening with the y. So this is what we're going to on the x, and then what's happening in the y, is it going up, increasing, is it going down, decreasing, or is it staying the same, which would be constant. So now we're going to talk about relative min and max values. So the points at which a function changes is increasing, decreasing, or constant behavior are points of relative minimum and maximum values. So a minimum is where we go from decreasing to increasing or constant. And the maximum is where we change from increasing to decreasing. So I like to think of a relative minimum as like the bottom of a valley, and then the maximum is like the top of a peak or the top of a hill. So if we go here, we see that we have a change in increasing to decreasing. So this is going to be an example of a relative maximum. It's like a peak. And if I were to ask you to tell me what that point was, we have a relative max at -2, and it looks like it goes up to about 3. So we have a relative max at -2, 3. Now, the reason it's only a relative is because it's not the maximum point in our function. We can clearly see this is a maximum point in our function. It's the highest point, but it's where we're changing from increasing to decreasing, and it causes it to look like a kind of like a peak or a mountaintop. So now down here, we have 2 more changes in behavior. This one goes from decreasing to constant. So this is considered like the bottom of a valley. So we would say at 2, it looks like it goes down to -3. We have a relative minimum, as well as right here, for -3 is also another relative minimum. So relative max, -2, 3, and these are our 2 relative minimums. On this next graph, where we have our 2, so we have this, and this point where we're changing. So this one looks like it's at -1, -2. And that would be considered our relative minimum because it's the bottom of a valley. And here we have it at 1, 2. And that's a relative max because it looks like the top of a mountain. For this example, we have 1, 2, 3. 1, -1 is a relative min. So 1, -1, as well as 4, 1. So these are our relative minimums. And then right here at about 3, 1 is our relative max. Because we're going from increasing to decreasing. Now moving on to something that's a little bit different, we also in this section graph piecewise functions, and they can be a little bit different than your regular functions because they have two pieces to it. So the graphs might look, the one graph might have two pieces that look completely different. So whenever we do this, we always start by drawing two XY tables or however many parts of our piecewise we have. So we're going to draw an XY table for the top function. All right, so there I have my two functions and my two XY tables. So we always start by plotting or plugging in this point for X. Even though here it's greater than this point, we still need to find what that value is. So in this XY table, I'm going to put 1 as well as in this XY table. And now if I look at the rule for 2x plus 3, it says x less than or equal to 1. So I want to choose x values that satisfy this. So less than or equal to 1, we could say 0, we could say -1, we could say -2. And that's probably plenty. 4 is a good amount to have. For our second equation, x is greater than 1. So we want to pick x values that satisfy this. So we could say 2, 3, and 4. And now we want to go through and plug in 2x plus 3 for all of these x values and -x plus 4 for all of these x values and see what we get. So when we plug in 1 for x here, 2 times 1 is 2 plus 3, we get 5. If we plug in 0, we would get 3. If we plug in -1, we get 1. And if we plug in -2, we get -1. So we plug in x in here, and then we get out these y's. Same thing over here. So now we're going to use this equation. So we get 3, some black, we get 3, and then we get 2, -2, we get 2, and then we get 1, and then we get 0. So now we want to actually plot these points. And so when we plot these, for the top equation, we can be equal to 1. So we're going to plot all of these with a closed circle. So I go through 1, 1, 2, 3, 4, 5 on my y. There's 1, 5. This is where my graph is going to start, right at this point, 1, 5. And then I'm going to go to 0, 3, which is right here. And then I'm going to go to -1, 1, which is right here. And then -2, -1, which would be right here. And I start at my starting point, and I'm going to connect these and draw an arrow because my line is going out this way. For this equation, I'm going to do the same thing for this xy table, but since x has to be greater than 1, this point is going to be an open circle. So I go 1 up to 3. I draw an open circle because it's not actually equal to that. Sometimes I like to put a little open circle here to help myself remember that. And then I plot the rest of my points, and that is still my starting point. If we didn't plot that point, so plot the points, connect them. If I didn't plot this point and I just started with 2, 2, I would be missing out on all of this part of my graph, which is not what we want. And so that's how you graph the two piecewise functions. They're two separate parts. One has a closed circle when it's equal to one has an open circle when it's not. And then you draw the line starting from that starting point and going in the direction of your points, and always make sure you have an arrow on the end.